Good morning. So today we're going to start with scientific notation. Y'all did great on your quizzes, by the way. So very, very proud of y'all for all of the hard work that y'all have been doing lately on exponents. But today we're going to talk about scientific notation. Scientific notation is a way to write a very large number and a very small number. So, a very large or a very small number in a compact form. Okay? So what you'll have there is that you'll have a decimal value. So it looks something like this. It's a decimal value multiplied by a base of a 10, and that 10 is going to be raised to either a positive or a negative exponent. So it's going to look something like this, like 1.2 times 10 to the fourth power. Okay, that would be scientific notation. Well, why do we learn this? We learn this because a lot of times in science and chemistry, you'll see numbers written in scientific notation. So scientists use this and mathematicians. Okay? Alright, so to put a number in scientific notation, you'll take you're going to be taking a very large number, so it's going to have a lot of zeros at the end of it, or a very small number, which would have a lot of zeros at the front of it. Okay, so you're going to put the decimal behind the first digit, so behind the first number. Okay, then you are going to count your decimal places. Okay, whatever you count, this will be your exponent. Okay, so the decimal places that you're counting is going to be the exponent on your base, on that base 10. Okay, so then you're going to drop off all the zeros. Okay, so drop the zeros, put zeros off the problem. Okay, so let's look at an example here. So, more than 6 billion pencils are manufactured in the country each year. Write this number in scientific notation. So this is a very, very large number. Okay, so this is very, very big. So we want to write this in a form in scientific notation. So I'm going to be moving that decimal. So I'm going to take, I'm going to take a pen here. So I'm going to take, this is my decimal point right here, right at the end. Okay, so I'm going to take that and I'm going to move it, and I'm going to move it by that 6. So I need to count. So I've got 1 place, 2, 3, 4, 5, 6, 7, 8, 9. So my number is going to be 6 times 10 raised to the, I counted 9 places, and I'm going to the left there. So when I move that decimal place to the left, you add your exponent. So that is a positive exponent there. So I move that decimal place to the left, so it's going to be a positive 9. Okay. Alright, so let's look here. 8.0. So each second a star converts 8.0 times 10 to the 9th tons of hydrogen into helium and energy in the form of gamma rays. Write the number in standard form. Okay, so this is a positive exponent. So if I wanted to write this in standard form, okay, then it's going to be 8, and I'm going to move it. Oops, I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops, it's pretty ugly. So we'll add those zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Just put your little commas here. Okay. Alright, so let's look at some examples here. So writing numbers in scientific notation. So here I'm going to take 880,000. I want to put it in scientific notation. So we move the decimal place. So what I'm looking for, my number is now going to be 8.8. Okay, because it's going to be behind that first digit. So that's where I want my decimal point to be now. So now I need to count. So 1, 2, 3, 4, 5. So this would be 8.8 times 10 to the positive fifth power. Okay. Same thing over here. We want the decimal to be in between the first digit. Okay. So we now need to count. So we're moving our decimal to the left. 1, 2, 3, 4, 5, 6. So this is going to be 7.5 times 10 to the 6th power. Okay. This one we're wanting to put it way down here. Okay, this is a huge number, right? So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is going to be 1.0 times 10 to the 11th power. Okay. So now I'm going to be moving my decimal place to the right. So that means I'm going to be subtracting. Because this is a really, really small number here. Okay. So I'm moving it. I want it now to go and be 2.03. So I need to count 1, 2, 3, 4. So this is going to be 2.03 times 10. I moved it to the right there. So it's going to be, what did I say? 1, 2, 3, 4. So 10 to the negative 4th power. Okay. Same thing here. So we got 1, 2, 3, 4, 5, 6, 7. So this is going to be 5.145 times 10 to the negative 7. Okay. Here, 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be 8.0718 times 10 to the negative 8. Okay, so basically when you are moving the decimal, okay, so when you move the decimal to the left, you're going to add. When you move the decimal to the right, you're going to subtract your exponents. Okay, alright, so in standard form now, so here I've got 5.14 times 10 to the positive 6. Okay, so that means I need to, this positive 6 means I need to move my decimal, okay, because I need to get rid of the exponent, so I need to move the decimal to the, good job, so to the right, okay, so I'm going to have 514, and I'm going to move it 1, 2, 3, 4, 5, 6. And you're going to add those zeros. Okay. So here you're going to have 6, 3, 6, 9. And it's 1, 2, 3, 4, 5, 6, 7. Okay. So here we've got 7.97 times 10 to the negative 4th. So to get rid of these exponents, I would need to add an exponent of a positive 4. So when you add exponents, you're going to be moving to the left. Okay? So this is a very small number. So 1, 2, 3, 4. Because you want an exponent of a 0. Okay? So here we've got a 6, 8, 8, 8. 10 to the negative fifth. So 1, 2, 3, 4, 5. Okay. So left, add, right, subtract exponents. Okay. All right, so let's talk a little bit about, let's talk about numbers that are larger and smaller. So if we wanted to compare the numbers, we would have to, you get two ways about this. You could get these in standard form, or you could get these and compare the exponents, okay? So it doesn't matter, however you want to look at it. So this first one here, we've got 7.3 times 10 to the negative fifth. So what does that mean? That means 1, 2, 3, 4, 5. So it's going to be a really small number, and this 5.5 is going to be a very large number because that's a positive exponent. So 1, 2, 3, 4. So when I compare these two numbers, it's easy to tell which one of those is going to be larger. Okay, so the one here with the positive exponent is going to be the larger one. Okay, but what about here? We got 6.1 times 10 to the second, and I've got 2.8 times 10 to the fourth, okay, to the fourth power. So I could change this and I could say 6.1, but instead of having 6.1, I would move it 2 places, okay, to the right, 1, 2. So that'll be a 610, or it's going to be 2.8 times 10 to the fourth, so 1, 2, 3, 4. So which one of those is bigger? Okay, the one with the largest exponent there. Okay, what if I got these, tried to get these in the same scientific notation here? Sorry. So what if I wanted to get 6.1 times 10 to the second power? What if I wanted to get that to the fourth power? What I would do there is I would move the decimal 2 places to the left. So now this is going to be 0.061 times 10 to the fourth power. Okay, so now I can compare 0.061 and 2.8 times 10 to the fourth, because those are in the same units. They are both raised to the fourth power. So the larger number there is going to be 2.8. Okay. All right, so let's try to do that in this one here, number 3. So I've got, this one is raised to the negative 5th power, and this one's raised to the negative 7th power. So I want to get these in comparable exponents, okay? So if I wanted to compare these and get them in the same exponent, this is going to help us add and subtract when we get them in the same exponents like that, okay? When we get them in the same exponents, we need to, let's try to get it into the negative 7th exponent. So if I wanted to take 7.5 times 10 to the negative 5th, okay, I want to subtract, so I need to subtract a 2 by that negative 5. So negative 5 minus 2 would give me a 7, a negative 7. Okay, so to get that, then I would need to move which way? Let's go back over here. Okay, we're going to move to the right, add, move to the left, subtract. Okay, so over here, I would move to the right. Okay, so if I move to the right 2 units, so now that would be 750 times 10 to the negative 7th power. Okay, and then I'm going to have that 3.4. Now they're in the same units, they have the same exponents, so we're going to be able to compare those. So which one of those is bigger, 750 or 3.4? That 750 is larger. Okay, the hardest concept to understand is this right here. Okay, when you move to the right, you'll add exponents. When you move to the left, you'll add exponents. and when you move to the right, you will subtract your exponents. Okay? Alright, so let's talk a little bit about adding and subtracting. So, scientific notation, to add and subtract, the exponents have to be the same. So we have to make them the same exponents before we can add and subtract. Okay? And just like I said, when you move the decimal to the left, you're going to add your exponents. When you move it to the decimal to the right, you will subtract. Okay? So now remember, just remember, this is the same thing. 3x squared plus 2x squared. The exponents have to be the same for us to add and subtract, right? So we have to remember our rules of exponents, okay? So exponents have to be the same for us to add or subtract, okay? So we're going to do a few in this little set here. Okay, so let's look at the first one here. So I've got 9 times 10 to the third power plus 2.3 times 10 to the fourth power. Okay? I have no idea why that says number 5 right there. But let's look at number 5. 9 times 10 to the third power plus 2.3 times 10 to the fourth power. Okay, so I need to get these in comparable exponents. So, two things. Remember, when you move to the left, you will add an exponent. So it doesn't matter which one you move, but you just need to get them in the same exponents. Okay, so this one I'm going to move this 9 times 10 to the third. I want to make this a 10 to the fourth. Okay, so I want to make that a 10 to the fourth right there. To make that a 10 to the fourth, I'm going to have to move the exponent to the left. Okay, so I'm going to have to move it to the left, so that means it's going to become 0.9 x to the 10. X times 0.9 times 10 to the fourth. I'm sorry. Okay, and so now here you will just add those two numbers. So 2.3 plus 0.9 is going to be a 3.2 times 10 to the fourth. Okay. All right. So this we have let's look at number 7 here. So we've got 10 times 10 to the fourth plus 2.8 times 10 to the sixth. Okay. So here we want to be able to compare these two values. Okay. So to compare these two values, we could change that 10 to some type of scientific notation where my exponent now is going to be a 6. So I want to make this a 10 to the 6th power. So to do that, that means I'm going to have to add the decimal. So move the decimal 2 places to the left. Now they're in the same exponent. Okay, so we'll say 0.10 plus 2.8. So that is going to be a 2.9 times 10 to the 6th. Okay, so let's do subtraction over here. So let's look at this number 2 right here. Okay, got 5 times 10 to the third minus 8.9 times 10 to the fourth. So I want to move my decimal. Okay, so we'll move this decimal over here to the left, and then we will add an exponent up there. So this is going to be 0.5 minus 8.9. So 0.5 minus 8.9 will be a negative 8.4, and then this will be times 10 to the fourth power. Okay. All right, let's do number 4 down here, another subtraction one in my crazy numbering system here. So move your decimal. So we'll move that decimal on the 10, and we'll make this make it a 1.0. So when we move it to the left, we're going to add an exponent. So that exponent of a 2 is going to become an exponent of a 3. So now we can say 1.0 times 10 to the third minus 7.79 times 10 to the third. So 1 minus 7.79 is going to be a negative 6.79 times 10 to the third. Okay? Alright, now we're going to talk about multiplication and division. This one's a little bit easier because you don't have to change your exponents to get them the same. Okay, so what we're going to do is we're going to multiply or divide our numbers. Okay, and then we're going to use our rules of exponents to either add the exponents on our base 10, or we're going to subtract. So here we would add our exponents because all of this we are going to be multiplying like bases. So we add the exponent, and then over on this column we're dividing all of our numbers together. So that means that we would subtract the exponents. Okay. So all you do is just multiply the numbers, okay, and then add your exponents or subtract, okay? So we'll multiply, so let's look at this 5 here. So 6.7 times 6.2, so 6.7 times 6.2 is going to be a 41.54, okay? And then this is going to be times 10 to the negative 2 plus a 2, which is a 0. But remember, we have to put this, I didn't say it, but we want to put these answers in scientific notation. So scientific notation, remember, is moving the decimal place over 1, okay? So if I move it over 1, so this is now going to become 4.154 times 10, and I'm moving it to the left, so we're adding an exponent. So it's going to be 10 to the 1, okay? Let's look at number 7. So number 7, we'll say 5 times 7. So 5 times 7 is a 35. And this will be x to the negative 3 plus a negative 2, which will be a negative 5 power. Move our decimal over, make it in scientific notation. So we're moving it over, so it's going to be 3.5 times 10, and we're going to add a 1 to that negative 5. So negative 5 plus a 1 is a negative 4. Okay, alright, so let's go over here and look at number 1. So 8 times 10 to the 4th divided by 4 times 10 to the 8th. Divide your numbers. 8 divided by 4 gives you a 2. And then here we're dividing our numbers, so we're going to subtract the exponents. So 4 minus 8, so it's going to be a negative 4. Okay, let's look at number 3 here. 3.9 times 10 to the 3rd divided by 2 times 10 to the 5th. So 3.9 divided by 2, if you divide that out, that's going to be a 1.95 times 10, and that's going to be 10 to the 3rd, and divided by 10 to the 5th, so we're going to say 3 minus 5, which is going to be a negative 2. Okay? Alright, so that's the rules of exponents, so I want you to finish that up, that worksheet up, and work on your homework. You'll have a great day.